Hi, it's Matt Williams from Volumes of Fun here, and I just wanted to put together a quick video showing you the progress I've made integrating our Cubiquity voxel terrain engine with Unreal Engine 4. It's only early days at the moment. I've only been working on the plugin a short while, but it's got to the point where I have something to show, so I thought I'd show you what I've got so far and what you can do with the plugin in its current state. So all I have here is the default first-person template C++ project loaded up in the editor. And all I've done on top of that is put into the plugins directory of the Cubiquity demo project the Cubiquity folder which contains the plugin code. I've then rebuilt the source code and restarted the editor, and so here I am with all the Cubiquity functionality present. So over on the left hand side we have the Cubiquity folder. This is loaded from the plugin, and inside that you can see we have a single blueprint called Cubiquity Terrain. This is the main actor you'll be interacting with, and it'll be your main first port of call for any implementation you need to do. On top of that, we have a materials folder which has just a simple triplanar texture, and a textures folder where I've copied in some simple textures from the default Unreal Engine editor. So, in order to get this going, it's as simple as creating a single instance of the Cubiquity Terrain object. It takes a few moments to load since it's loading the volume from disk as well as generating the meshes for it, and you can see that there we have it, a full 3D rendered voxel terrain using the dual marching cubes surface extraction method. If we switch over to wireframe mode, you can see that it is indeed a full 3D mesh which is being loaded from disk and then being rendered inside Unreal Engine. As well as being able to visually show the mesh, we can also interact with it as a physics object. So if we grab our player start object and bring it up here and drop it on top of the mesh, level it up with the bottom a little bit and throw it over there. If we click play, you can see immediately we are inside the in-editor preview mode, and we can run around on the train. You can see we're going up and down as the train does. There are walls which we can't walk through, and there are underhangs we can go under. So it's all working correctly as you'd expect a voxel terrain engine to do. But of course that's only simple rendering. We want to be able to do more with our voxel terrain, for example live editing of the terrain. So since we are using the first person shooter template from Unreal Engine, if we go over to the game blueprints folder, there's a blueprint for the projectile. So inside the game, I'll show you quickly. If you click the left mouse button, it shoots projectiles across the map, which, as you can see, bounce correctly and interact with the mesh in the way that you would expect, going underneath overhangs and falling off the edge and things like that. So if we go and edit this projectile blueprint, and we want to be able to add some interaction with the Cubiquity engine when an event happens. So what we're going to do for starters is make it so that when you fire one of those projectile balls, when it hits the mesh, it's going to add on a small piece of a small blob of terrain, so you can extrude shapes from it. So we start with the hit event. So this is an event which is triggered whenever this actor interacts with some other actor in the scene. And the important thing here is the other actor. So this is the actor that the ball of the projectile is hitting against, which in our case is hopefully going to be the Cubiquity mesh. As an implementation detail, the thing we have to cast it to is Cubiquity Octree node, since that's the small subset of the terrain that is actually hitting against. I'm hoping to neaten that up a bit, but in the meantime, that's the actual object, the actor that the ball is going to be interacting with. Once we've got that, there is a method to get from the small submesh up to the full overall volume, so we can call getVolume on the Octree node, which is going to return a Cubiquity terrain volume object. So once we've got that, it's a simple case of pulling off and seeing inside the Cubiquity section there is a sculpt terrain function. So this is a function which is going to edit the mesh in real time and cause everything to be updated. So we want that to be called after the cast. It takes a number of options, most important of which is the world position. So this is the position in world space that you want to sculpt the terrain. So we are going to use the hit location from where the ball hit the mesh. And there are a couple of other options, inner and outer radius, which define the size and fall off of the brush that we're going to be sculpting with, and the opacity, which is, if it's positive, it's going to be adding stuff on; if it's negative, it's going to be subtracting stuff away. And all we want to do finally is destroy the projectile that we're currently inside, so that it doesn't bounce over the terrain and cause too much havoc. So if we save that and compile, so what we're doing here is when the projectile hits the mesh, we're checking whether it indeed hit the mesh, getting the interface to the overall volume, and calling a sculpt function on it, which is going to add a small amount of terrain onto the place where the ball hit, and finally destroying the projectile itself. So if we close that and go back into play mode, you can see here we're inside play mode, and we can fire the gun, and you can see that it's correctly causing the mesh to be deformed. We can, as well as shooting it on walls like that, you can shoot it on the floor, which causes the floor to raise up, and if you can get it in the right way, you can see that it is in fact not just the height map editing, but it's causing it to actually create a full 3D mesh effect. So in that way we can, anywhere we wish, cause extra bits of terrain to appear, so that we can edit the terrain in real time. So if we go back to our projectile blueprint, and we can change the inner radius to be something a little bit larger. So if we change the inner radius to be 2.0 and the outer radius to be 4.0, and save and recompile, you'll notice that inside the editor those changes we made have been reverted, but when we go back into the game they are in fact still present. This is due to some persistence problems that I haven't quite worked out the best way to establish yet. But anyway, you can see that now if we fire, it's causing much larger blobs to appear, which we can of course climb up on top of and allow ourselves to run around in it very easily and carve it in real time. Okay, finally, if we go to the projectile blueprint and change the opacity to be minus 0.8. So as I said, if the opacity is negative, then it's going to be subtracting terrain rather than adding to it. So if we once more click play, inside the editor you can see we can fire the gun, and it's removing material from the terrain. We can go over to some sort of wall area, like this for example. Oh, fell down a hole there. And we can run through, since it's being live updated, the collision mesh, so that we can interact with it however we wish to. Of course, these are just examples. You could, and in fact I'm planning on working on a set of simple editing tools so that you can simply draw around the terrain, extruding and carving as you wish, to be able to create any sort of shapes you wish. As well as that, you can paint the terrain and change the materials that are being shown, and that is all things that are going to be implemented before I put out the first preview release. So thank you for listening, and do follow us on YouTube, Twitter, Google+, and on the Unreal Engine forums, and of course our blog at volumesofun.com. Thank you for listening.